So good afternoon or good morning, everybody, dependently on the region where you are. My name is Enrico. I work at CERN. I'm operating Ceph in the storage group here. And welcome to the science meeting for Ceph. This is a bi-monthly meeting. It happens every 2 months. We are trying to make this meeting popular again. It was very successful, very interesting in 2023. Last year, the main person responsible for this meeting was busy with other commitments. So we're now trying to bring it back. This is meant to be an open call. It primarily targets Ceph operators and experts in various open science labs, big research centers, and university, but clearly the call is open to everybody. And the main purpose of the meeting is actually to share some experience among us, uh, nice, interesting features that we are testing out, upgrades, procedures that went well or maybe not so well, and other technical things that we have learned in the bad or the good way. We are also trying to bring a topical presentation to this meeting. In this specific case today, Mattia has kindly agreed to give a presentation about CephFS tuning. So Mattia, if you agree, I would leave the floor to you.
Sure.
And clearly, questions and comments are very welcome. I will try to
Yes.
moderate the meeting a bit. I guess that ideally questions and comments should come at the end, but participants are clearly welcome to
Yeah.
use the group chat if they wish to throw a few messages while you're
Yes.
presenting.
So yeah, consider that I won't be able to actually read the messages apparently with the current setup. So to me, it's also fine if you interrupt. So the presentation, it's very quick, very brief, I would say. So I get the honor of doing this first round of presentation. Also, I would like to mention that the idea here is that the presentation should be something that everyone can pick up. As you'll see, like I'll set the bar very low. So the idea is that you have like an hour or an hour and a half, and you put together whatever you want to share with the group and ask for feedback or like use it as a starting point for a discussion. That said, now that I adjusted everyone's expectation, we can get started. My name is Mattia Belluco. I work for ETH Zurich in the scientific IT services of ETH Zurich. It's a let's say heterogeneous group that does uh, everything science for departments and yeah, and at various institutes. It's part of the central IT services of ETH Zurich. What do I use? What do our team use Ceph for? So we use Ceph for as a backend store for a trusted research environment. Here we have around 500 researchers, and we have around 3.2 petabytes of data stored there. As you can see from the graph on the bottom right side, we run a platform that's actually growing. Can you still hear me? Everyone's fine? I heard a comment.
Yep. Yes.
Okay, perfect. And yes, and we selected Ceph because of its scalability features, and also because we wanted distributed file system for the platform, and that's what we actually started with in 2021, I think 22, I guess, went in production. So the platform was pre-existing when we actually plugged Ceph in, and that's when we actually start to see a lot of adoption. Just a couple of words about how we actually started our CephFS journey. So we followed the best practice that are available in the community. We used the spindles, but with separate wall plus DB that was put on fast devices. Our CephFS has a metadata pool, which is also on fast devices. Then the file system root is on a replicated pool. In our case, it's not a fast pool, it's still like a spindle based. And then the the evaluation of the selection of the AC algorithm, as I mentioned later, is something that we didn't put too much thought on, but something that probably we should have target yeah, dealt with in a different manner. And then before starting everything, we also took some time to validate the hardware components that we received from the vendor. So as an example of what we found out during this first phase, you can see here two graphs that show like the NVMe drives that we have on each of our OSD nodes. There are 4 NVMe drives each, and then all of a sudden we have this like a graph on the right that displays like one NVMe seemingly outperforming the other 3. Um, but that's of course not the case, because if you compare the two graphs, you see that actually the orange labeled NVMe on the right side has the value of all of the other NVMe on the left side. So in this case, we had like 3 underperforming NVMe's on a node, but luckily we spot early on. So they have about half of the performance that you have, and that's actually one of the mystery of hardware. So we got them replaced, and everything was working well after that. So we went in production with a Ceph system, and of course, going to production is also when you actually have to say confront the reality. So all your synthetic benchmarks actually become lose some of their meaning, or like even if you try to think and devise benchmarks that can actually mimic the user workflow when you go in production, is most of the time another story. In our case, we started with Pacific release, and we did all the benchmark with a single active MDS. We did a few things before entering full production mode. We moved data from a pre-existing system. We also did um, a gradual ramp up of users, so of individual project to the new system. But then, like, we started to find out that the current of the configuration at the time, the initial configuration was not actually up to the task of a productive use case, at least for our users' workloads. So we started actually looking into the tuning part. CephFS well, Ceph in general has a lot of knobs that you can turn. Most of them are well documented, but still, like, some are surprise, can give surprise. We started with let's say basic. So we decided that okay, since we had issue with the metadata not be able to serve enough requests, we start tweaking this value up, and we got to the current value of 7 active MDSs, but there was like an incremental change that we applied, because initially our incremental increase was also followed by a sudden increase in the request per second counters that CephFS kindly provides as a metric, and we realized that most of these requests were actually just the MDS is ping-ponging the subtrees when there was activity on some of the directories in the CephFS file system. So like basically we got up to 3, and then we start pinning project directories to dedicated MDS daemons, and then that's when we also started adding additional MDSs to cope with or to avoid pinning too many or too big trees to single MDSs. So that's like how our tuning journey started, but of course it was not that was not the last thing we tweaked. So we had to actually lower the number of capabilities per client from the default 1 million to 500,000. There is a very nice benchmark, but I didn't try to reproduce, but of someone actually claiming that reducing it even further helped him get steady state requests per seconds on like his workload, as opposed to actually having a big value. I think that like the value that they tested with was around 200,000, but then like maybe someone tried to follow this this person footstep and have something to report later. We actually are running with very big cache limit. So the current value for us is 110 gigabytes. This is mostly due to like the difficulty of pinning trees in in, let's say, in a consistent manner if you have very heterogeneous share sizes. So we have share sizes that goes from 1 terabyte to 1.2 petabyte. So for us, it's very difficult to actually allow, and splitting like this 1.2 petabytes is also something not reliably, that we can reliably do, because we don't know the access pattern inside the tree. So in the end, we ended up kind of targeting the cache limit towards the biggest share that we have. And since the VMDS node that we're using allows for it, we actually went a little bit higher than recommended, I guess. We did a few other tweaks following an outage that we had, where MDSs could no longer keep up with a burst in activity. These tweaks were actually done. So all these tweaks actually were actually done with Pacific. So some of these things, as we'll see later, maybe it may have changed in the most recent release. But anyhow, what we did was actually increase the cache reservation to bump basically the available cache size that LDS keeps for new request from 5% to 10%. And also like the MDS cache threshold, which is actually when the MDS issue a warning of oversized cache, we actually lower it to 10%, so 110%, because we also wanted to actually be warned in time when some pathological scenario were presenting themselves. And then trim decay and trim threshold were something that we tweaked because of we wanted to dedicate some times for the MDS to be able to trim the cache and not being actually overwhelmed by new requests and then being delayed in the trimming part, which usually in our experience it's one of the first indicator of a failure about to happen. Curiously enough, and I think for this we can also have a little of exchange later, the threshold for the cache trim changed dramatically with Quincy. So it was 64K for Pacific when we started, and we bumped it to actually, quite a high number. So 339. I don't even remember how we got to this number, to be honest. And now Quincy, though, the default value is much higher. It's 4 times the Pacific one, and it's still less than ours, but still like on the let's say leaning towards our value. One other thing that we worked on is the deletion operation. So in our case, the deletion operation was very expensive, with people deleting millions of files at once, with, of course, like a cluster which is not only doing deletion. I mean, the problem is that when this operation compounds with each other, and then you have like the deletion operation all of a sudden being run together with some reads, some writes, and like that's when we saw like a slow request. And another like a warning that you don't like to see on the Ceph health report. And therefore we decided that we could live with slower deletion if that allowed the cluster to behave more consistently for the actual workload. One I think last thing that we tuned is the MDS recall. So this is, as you can see, there are the values that we're using, and then like the default in Pacific and the default in Quincy. In all these values that you see here, we are about like middle ground-ish. So apparently like the Quincy went even further in this, so the Quincy default went even further in this regard. But of course, given that we fixed this value, when we upgraded, we retained this from the old tuning that we have done. The MDS failover is also something that in our system was not working with default timeouts. So we actually needed to up the MDS beacon grace, which is actually the beacon that decides whether an MDS is responding or not. It needs to be, let's say, failed for another MDS to take over. and we had to actually bump this value like to 5 minutes to be on the safe side that an MDS failure could actually trigger an MDS failover properly. So these are like a little bit of overview of what we just discussed. So the values that we are running in production with. I think it's interesting to note that the Quincy change in default, it's not in the release note. I guess there was some discussion in the mailing list about the tooling to confront like new defaults with existing ones. But for us, at least for me, that was a big surprise. So I actually discovered that the value changed so dramatically when I was preparing a presentation for FOSDEM. And yeah, and then I was comparing my values with the Quincy one. I was saying, wait, like we have less than the default. That's a little bit strange. And indeed, the default change from Pacific. Overall, like what we would do differently. There is some echo. What we would differently in our for our setup, and also like to in our journey for CephFS up until now, is actually to dedicate a fast pool to the replicated so to put the replicated flash pool on a fast on fast devices, because for us the overhead of needing to rebalance these tiny objects that are put in the root of a file system is a little bit too much. I mean, we could easily let's say make it much faster with very little effort, also like in terms of investment, because of these basically zero byte objects that are getting moved around when a disk fail. And then like, yeah, what I was mentioning before, this is the last slide, the selection of EC algorithm. So we are running with EC 2+2. That's because for us, like the 4+2 was not really cutting it performance-wise in the run read and run write scenario type. But we went with the default, also like kind of push back from some of the, let's say, belief, like the fact that some of the better algorithm would only work on Intel CPUs, and we're not sure that whether we're going to use Intel CPUs forever. But this actually turned out not to be the case. So there is a very nice talk from last Cephalocon from Jimmy Pride from IBM that actually did some tests and also like, yeah, debunked this belief about ISA-L, but works also, turns out to be working very well on AMD CPU as well. So yeah, that's the bulk of my presentation. I hope you could listen to it because I didn't see your faces I was mentioning. So yeah, that's it.
Thanks a lot, Mattia. This was definitely very much interesting. Yeah, you could. I was about to say you could stop sharing if you wish to see all the attendees. There are, I guess that there are a few questions. See, Martin has raised his hand. So, Martin, uh, you're muted. We can't hear you. Okay, much better now. Martin, do you have a question to Mattia?
Yeah, I would like to know, did you also experience the overspill warning when using the WAL and DB on a fast device? And what kind of size did you use? How did you do the sizing for WAL and DB? Did you use a common block device for WAL and DB, or did you use two separate fast devices?
Yeah, so no, so we used a single common device for WAL and DB. So we specify basically only the DB with the assumption that the WAL would follow the DB fast device specification, and we'd never experienced the overspill. We didn't also follow the 5% recommendation that some time ago popped up into the Ceph documentation, which was mostly targeted to RGW workloads more than RBD or CephFS. In our experience, so we are using we're using 1.6 terabyte NVMe's, and they serve 12 devices. So the DB size is a little more than 100 gigabytes per device, and that turns out to be plenty. So we
This is
didn't
interesting
really.
because I typically use about the same size, but I experience the overspill rather common. I can resolve it pretty fast in the meantime with the most recent Ceph when calling the Ceph OSD compact call.
Mhm.
But it obviously shows that, well, it should be done automatically. You know, there's no good reason to have to do the compacting manually. That shouldn't happen. And so I'm wondering what happens. But another question, thank you for the information.
Yeah,
Is,
can I ask you just a curiosity? So the
sure.
use case where you see the overspill is still like CephFS.
Yeah, now our use case is mainly RBD.
RBD. Okay, thanks.
Yes. So for virtual machines providing block devices. So it's a little bit different use case, and maybe this is, I will further investigate if this makes a difference. Okay, I would also like to know if you experience when you do the benchmarking or when you have a lot of load, a significant amount of CPU used for the OSD daemons. Do you also experience that?
So not really. So our expectation was that using Erasure, we would have like a busy CPU all the time. But for us, at least, that's not the case. So we have like we're not running on low powered hardware anyway. So we are running on Xeon Silver. I don't remember exactly which model. But overall, like the cluster is like if you look at the CPU usage, is not doing much. So um, the actual OSD processes that are using a lot more resources are the one that are serving pure fast storage, which in our case it's actually co-located together with the slow devices in the same nodes. So you can tell just looking from the top what's actually which daemons is doing what. So if they're actually serving a spindle or a fast device.
Okay. Can you give a rough estimate about the ratio of OSD versus number of cores available?
It's mostly one-on-one physical. So I think we are oversubscribing it a little bit, but I would need to check. I can check
And you use hyperthreading or not?
Hyperthreading is enabled, but we do like the calculation with physical cores. So we use
With physical
hyperthreading
cores,
as like
not
a
the virtual
like
core.
as a bonus. Yeah.
Okay, thank you. One last question. Do you use CPU pinning, which might be useful if you have a
No,
one-to-one relationship?
no, we don't. Also because we have dual socket CPUs, and like still the devices are not equally split between the NUMA cores. The NUMA cores. So like um, like we would actually be penalizing some of the USD if we did that. So we decided not to.
I can report that doing the proper pinning only gives about a 10% performance gain, even if I make sure that when I use very fast NVMe drives and I do the pinning for the CPU and I make sure that I'm correct memory channel and whatever, it's about only about 10%. And for me, for my
Well,
benchmarking, it looks like the big bottleneck is the OSD daemon.
mhm. Still 10%. It's a good
Thank you.
it's a good value.
Martin, sorry, out of curiosity, if I could intercept. On your fast NVMe's, are you running one OSD daemon per device, or you're running multiple OSDs on the same physical device?
So the one that is serving only for us, the fast devices are serving the metadata pool,
Yeah.
and we run actually 4 NVMe's per device. For no particular reason actually. So the idea there was that MDS still needs like not so the metadata pool is not going to be like grow forever. It's not super big. We wanted to run more than one because people say that it's like easier to actually saturate the performance of those. Uh, and then we actually set on 4, but for other use case we use 2. So it depends. I mean,
Okay.
it's not really hard limit, but we use more
Okay.
than one.
We use typically multiple OSD per physical device when we use fast devices. The main reason is for historical reason, because I'm running several clusters. But typically clusters grow over time, and I want to have the size of the OSDs about equal. So at some point some years ago, I decided for 2 terabyte per OSD. So when I have an 8 terabyte OSD, I divided into 4 to keep the typical size, which makes the balancing and so on much easier. And also newer devices tend to be faster, so they can easily cope with this extra load.
Right.
And also previous versions of Ceph used to scale much better when you have multiple OSDs per device. I'm running now only 18 and 19, so it's Quincy and Reef. And for those, actually, OSD is capable of using multiple CPUs. So it doesn't scale that much anymore. So I think the difference is now smaller than it used to be. But for historical reasons, we typically run 2 terabytes per OSD.
Yeah. I'm just linking in the chat a blog post by Mark Nelson, which you may know, about running one or multiple OSD processes per NVMe. And this looked like it was a problem with previous releases of Ceph. But indeed, if you're on very recent ones like Reef or Squid, I think there were huge improvements there. So you don't actually need to run multiple daemons to squeeze out the performance of the device. But, okay.
Can I I have just a comment to follow up on Martin? Think about the overspill. Are those overspill caused by recent so cluster actually deployed with recent releases? Because for one, like the RocksDB sizes have been like a kind of liberated in more recent release, and like while some time ago there were actually fixed sizes for the RocksDB that may actually contribute to this overspill you're seeing.
Okay.
It was a freezing question.
Exactly. Okay, let's wait a few seconds. Let's see if he comes back.
The big difference is that the compacting is now much faster, and it works the first time. It used to be very strange. You had to do compacting, and then you had to restart the OSD, and then you had to do compacting again, and then you had, with some luck, you actually got rid of this warning. And this is not the case anymore. You can now do it in a running system. It typically takes about between 20 and 40 seconds per OSD in order to get rid of the problem. But so it improved, but it did not go away.
So, but so because I think we lost the initial bit of your reply. You have this problem also on newly deployed cluster, not just on
Yes.
upgraded.
Yes.
Okay.
But the remedy, which is the compacting command, Ceph OSD compact, now runs much faster than it used to run, and it's more reliable because it now works the first time. It used to take 2 rounds.
So I see there has been a question by Ken in the chat. He was asking you if you're using dedicated machines for MDSs. Then Ken, you're clearly most welcome to expand your question if you wish.
Yeah, it's basically just that if you have separate bare metal hardware just for the MDS.
Yeah, so like given our RAM, so the cache limit that we put, indeed we have dedicated machines. In our case is actually was I repurposed the HPC nodes, so we have hardware that is still like in decent shape. We try to actually repurpose, and these ones actually had enough memory for us to consider using them as MDSs. Yeah, so we run so we use the orchestrator, we use Ceph ADM, so we run multiple MDS daemon on the same machine. So yeah, in this case I think we're running 6 concurrently. and the max, because the machine has like around 600 gigabytes of RAM, so we know that it can actually in principle cope with 6 running concurrently. Although this never happens because we have redundancy, but yes.
All right, cool, thank you. One more question. So you mentioned that you have tested the ISAL profile for erasure coding, and are you using it?
No, so we did not test it. So that's
Okay,
why
okay.
one our regrets. So like because like it seems that performance wise, it's actually very, very interesting. And yeah, so like my information actually comes all from the talk I linked in the slides that I can actually make available somewhere, or I can actually extract the link. The because yes, so I saw that presentation at Cephalocon and I was very much like, okay, so this is something that we should probably have invested more time on.
Yeah, cool. All right. Thank you very much.
You're welcome.
Is there any other question to Mattia? Martin, please.
I would like to know, maybe I missed something with a connection problem and reconnected in between. Maybe you already told us. I'm wondering about some benchmarking results. Especially for the worst case scenario. So if a single of your users requires a lot of small I/O, like a database or whatever, how well does it perform on your system?
So we
And
don't.
maybe
We
you can
asked.
compare if you can compare it to other shared or distributed file systems. For example, when I run it, people always compare it to NFS, and I have problems of competing with NFS.
Yeah. So indeed, the same happens to us if I have workloads that have very, very small writes and reads. We still actually nowhere close to NFS performances. The database question is an easy one because we advise users not to put database on CephFS. It's really, really, really slow for database workloads, at least in our experience. So we have so the RBD. Well, it also depends if it's like a database that gets a query a second, but like, and if a query actually it's a quick one. But in our, yeah, indeed, something that we advise the user against. We're also running Ceph RBD, so that's with flash storage, and that's what we recommend users to use if they want to
Do you have an idea why CephFS is so much slower than NFS?
Well, my take is that it's like the whole architecture and stronger like compliant POSIX compliance that kind of like does not allow some of the NFS shortcuts with locking and such. But yeah, I'm no expert on that, so I would not be able to provide.
Well, actually, NFS claims to be POSIX compliant. It has some issues, which is well known. But you're definitely sure that those issues are not with CephFS. CephFS is fully POSIX, and
well, so the fact
the
that what
case, you know.
so what I can tell you is what the designer and the developers tells us. I don't have like any like internal like or additional knowledge about that. So they claim to be more POSI compliant than NFS. That's like and that's what I took, to be honest, I took at face value. I didn't really do any tests on that.
Is there any other question to Mattia?
But also like our experiences with tuning variables, like it doesn't need to be like all about what I showed you. It's like the idea is that if you have something cool or something that really was interesting that made a difference in your cluster, it's a good time to share it.
Let me ask you one thing. Have you ever considered multi-FS as an alternative or as a complement to multi-active MBSs?
So so like it's funny because we started with multi-FS in the early days, and then like as my former colleague Enrico, who's in the call, can testify, that we moved away from multi-FS because it seemed like it was anyway like kind of tweak or like kind of like work around, not super tested. And then Ceph came back saying, no, it's fantastic, it's stable, you can use as many as you want. So when we actually started with cluster, we wanted to keep things as simple as possible. Now we're thinking about possibly doing that, but the problem for us, it's like the data movement, right? So the ideally, like as I was mentioning before, since we have these heterogeneous use cases, we would have like an FS just for the share of 1.2 petabytes. So at least that can have their own MDS, they can have multiple active, we can try to pin them differently, we can try to use some other pinning strategy, but you may not want to use on all the shares. But yes, so yeah, I would, if maybe another thing that I would do again, I would do differently in Insight, it's also that one, evaluate a little bit more closely the multi-FS.
Yeah, I was asking because we're actually looking into that because of metadata balancing issues and because of let's say a wish to isolate client workloads a bit more one from the other. Because the way we run CephFS here is that people just get a share via OpenStack and then they mount it, and there is quite a diverse set of clients that we have around both Fuse and kernels at different versions. So this has been problematic for us in the past because there were issues in some specific releases that were not straightforward to work around. And then if someone is mounting via kernel, the fact that you ask them to roll back or to move ahead is not super easy. So we're actually evaluating multi-FS to try to isolate different sets of users which are more or less behaving in the same way or rather using the same Ceph versions one from the other. But we're not there yet, and we share the very same problem of moving the data from one to another, because eventually you have to copy all the files. There is no other way. So yeah. When you said the very early days of multi-FS, how early days were these? Because this
It's Mimic.
feature is considered like stable since Pacific, if I remember
No,
correctly.
actually, well, so the story of multi-FS is actually a little bit more complex than that. So multi-FS as snapshot were actually considered stable since I think, since Mimic, but not if, so they consider experimental, but stable if used separately. So they actually recommended of not using snapshot with multi-FS. And so you have to pick. Either you wanted to use snapshot or multi-FS. And at the time we picked like multi-FS. It was still considered kind of experimental, but working. We're not going to do much more testing, but the code is there. So we went for it, and it actually worked fine. So like since the Mimic days, so that's like at least my first CephFS cluster. Everything works nicely with the multi-FS part. We only had 2 file system, but yes, so the code was there. And then it's considered now fully stable apparently, so you can actually combine it with snapshot and other things. But
Yeah. So do you use snapshots?
no.
No. Yeah. I was actually wondering, can I just take the opportunity to create a poll on the spot? I'm not very familiar with the tool. Maybe it would be interesting to collect a few numbers from the attendees, like how many MDSs are you running? Are you using snapshots or not? Do you mind if I do something like this in the background? In the
Sure.
meantime, if there
You can
are,
also do it in the pad if it's easier.
yeah, that's also possible. Um, Can someone please provide some links to multi-FS? Sure. Yes. I'm happy
I
to
guess
do
you're
that.
more, you're more up to date.
Yeah, yeah. I will do that after, if you don't mind, Philip.
Enrico,
Also,
by the way, also with a multi file system, we were using a multi MDS on one of the 2 file system. One was
yeah.
serving one was only on fast devices, and we were using, it was kind of small, and we were using only one MDS. On the other one, that was pretty big, we were using multi MDS on that one, even if there are 2 file systems.
Yeah, so that's actually, yeah. I encourage everyone, like also if you have a participant, if they have like CephFS also use case or experience that actually diverge or like similar to ours, if they want to share like how their journey is going. So it's that video is.
Okay, apparently I have created a poll about multi-FS. Okay, Mattia, let me ask you another question. Do you do regular scrubbing of your file system? Yeah,
So
exactly.
I guess you mean forward scrubbing with them,
Yes.
right? So
Yeah.
when you extract the MDS, so to do the scrubbing part, and yeah. So no, we've done only once. Once we had like a major outage because we wanted to understand if scrub would detect any issue, since we kind of like put our cluster back together with some let's say application of strength. I don't know if I could say that otherwise, but no, so we don't regularly do that.
Okay.
It's something that indeed, yeah, one of the many things that would be nice to have. But actually, to a counterpoint, not a counterpoint, but an additional point to the multi-FS part is that you kind of avoid the issue of having all the eggs in the same basket. So you don't rely on a single journal and a single metadata pool. Well, metadata pool maybe, but at least not a single journal for all your CephFS users,
Yeah.
which when you have an outage, you start to reconsider if it's a good idea or not.
Yeah. So from your slides, I understood that initially you were using the automatic balancer that is provided by CephFS to even out the load across all the MDSs that you have, and then you basically moved away from it to do manual static pinning of different subtrees to different MDSs. Have you ever experienced problems while manually pinning large directory trees to an MDS rack that you liked particularly? Because we have to do that every now and then, and this has demonstrated to be problematic in several occasions because MDSs do have to do a lot of work when pinning away large directory trees, which are maybe in the cache. And this typically manifests, yes, as the spike of requests that you have mentioned. But we were also, like the cluster was also complaining about slow ops for metadata. MDS0 was actually struggling to keep up with the log segments, etc., etc., etc. So we're trying to do it in the most controlled way possible. But if you have to pin away like a directory with 1 million inodes, which is actually being used actively by clients, this is still quite painful. I don't know if you have some special tricks or you try to
No, we
circumvent
don't.
this problem.
So we don't. We pin them like early on, and we seldomly change the values. So basically, when we pin them, they're basically not used because they're actually newly started projects that have either very little file or anyway not much activity going on. And but yes, like my memory actually are quite vivid of trying to actually change runtime values for the pinning of a very busy directory, maybe trying to cope with excessive loads on MDSs and having like the export stuck at some level because like it's busy doing something and it's like waiting for the export to succeed, and then like if you're lucky eventually it works, if you're not lucky then you get into this kind of situation in which the MDSs then start to display more and more warnings and then like eventually fails. So yeah, indeed, no, I don't have any tricks, unfortunately. Actually, we suspect that was also the issue why the automatic balancer was creating issue to us, because when it started to actually move around the directory that were too active, then like and the activity was prolonged, because then the issue is like if you have activity which is not sustained, as soon as the activity sees the MDS catch up and like finish the exports or whatever it's doing. But if you have sustained activity, you risk to actually blocking a subtree in this kind of limbo state in which
Yes.
it should be on an MDS, but instead it still be served by the original one
Yeah.
because there's still no time to actually move it away. So I guess that's also what presented itself as an issue for us with the automated one.
Yeah. I fully agree. So maybe one comment on one thing that you mentioned about defaults. So defaults seems to be a sort of an issue. Sorry, not defaults by themselves, but the fact that defaults change from one release to another, and they can also like greatly changed as you were showing. There was a request for comment recently in the Ceph Dev mailing list. They're looking into developing a simple tool to actually do a diff of the defaults between between releases, like generally available releases. Every now and then we also get surprised uh, by defaults changing and not really being reported anywhere. So you have to look into the source code. Now it's a bit more practical because they have these YAML files. Previously it was some a.h files, I guess. So for instance, from our own experience, we got recently surprised by the fact that if you upgrade to the latest greatest Quincy, you get the default number of concurrent scrubs set to 3, and the default was 1 in the past. So we had like a bad couple of hours where latency was going high and everything was slow, and then you instantly realize that your OSDs are just very, very busy doing scrubbing. So if they
Interesting.
if they eventually implement such a tool, I think it would be quite useful, especially when planning for upgrades, to not be surprised afterwards.
If you have a link to the mailing list message handy, Enrico, maybe you can put it in the chat as well.
Yep.
I guess we need to move the chat stuff to the pad at a certain point in time. I don't know if it's an easy way to do that.
I'm not sure.
At least the material, like, I mean, not
Yeah.
discussion,
This
but
I
the links.
can take care of, no problem. But yes, thank you for reminding me that we also have a pad. Let me link the pad in the chat. So if you wish to share your name and the organization you work for, you're most welcome to list it in the pad, just to do a bit of tracking of the attendees in a positive way, of course. And I see that Frederick has created a new poll. Do you use an mClock or a WPQ as a scheduler? I think this is for everybody. And just to give a bit of context, if I'm not mistaken, WPQ is the default since Quincy onwards.
No, it should be the other way around. mClock is the default now.
Sorry, mClock. mClock is the default from Quincy onwards. Default from we cannot hear you, Frederick.
Cannot hear you.
Oh, now it's okay. Now it's okay.
Frederick, if you were saying something.
I think there was a lot of echo.
Yes.
And now he muted again. So I see he's typing something. We're moving to Reef tomorrow. Okay. Yeah. This is for, okay, so Reef, I guess latest greatest like 1824 from Pacific. Yeah.
34?
So my personal experience is that we upgraded and we let the scheduler to be the default, so mClock. And then during the first significant recovery operation, there was some backfilling getting stuck. And then we rolled back to WPQ, and I mean, rollback, we just configured the scheduler to BWPQ, and it all went smoothly. Just a side note, if you want to change the scheduler, you actually have to restart all the OSDs. It's not something that you can do in flight. So maybe they fixed it. I haven't followed this closely recently to tell whether there were
But-
commits relevant for this or not.
But sorry, Enrico, which version of Quincy are running?
Currently, we're running the last one, so 17.2.8.
Okay, and you still have issue with this one?
This is an excellent question because previously we were running 17.2.7 and we
Okay.
have seen a few issues, but in 17.2.8 we have not reevaluated
yeah,
the
but-
thing. We were just
No,
using
but
the
still,
API.
like, no, but still, like the change, it's I think in .6, I think. So between .6 and .7, I think there was a change in how mGlock worked. So I guess, yeah.
I think it also depends very much on the workload. So if it is blocks or objects or FS, the scheduler does have an impact there. And you can set different profiles. You can actually define some custom profiles. So maybe there are ways to steer the scheduler to do what you want to do. We were just very surprised to see some backfilling never completing. So, and then we checked the mailing list, and someone else was also referring this to a problem with the scheduler. But again, it is not said that this is true or true anymore today. Okay, Chris, do you want to elaborate a bit on this? You just posted a very interesting message.